Hey, this is Gary, and welcome back to my channel for developing a 2D framework using LibGdx. First thing I'm going to do is go over some things that I missed previously. And so for when you're setting the window size on a desktop, you would use the configurations, configure height and width to set that size. I was incorrectly thinking that I could do that through the base game. Turns out that's not true. So in base game, I took out the constructor that took the height and the width, and so that gets the height and width actually gets set via the resize method. So those values come in here. And then in the create method, I create a method to get the height and width based off of the graphics get height and width, just as an extra step to make sure that we got the height and width set. Now in base screen, I've also added down here in the setup screen, setting the height and width based off of the graphics height and width, so that our height and width matches. So originally I was planning on creating a simple game using my framework, and found out that I needed to add some more elements to our framework so that it could make that process easier. So in the simple screen, I added a boolean for render cycle. I'll show you how that works in a moment. And then I have another list of sprites, and it's called to be added. So down in the render child method, we set the render cycle to true when we start iterating through our list of sprites, and then we set it back to false. And so what that's used for is to avoid our concurrent modification to our list of sprites as they're being rendered. And then we check the list of to be added. And if it's empty, we don't do anything. If it's not empty, we add all the sprites to the sprite list, and we clear out our to be added list. Also in the render cycle, I added a check. If the sprite is removed, is turned to true, then we remove that element from our list. Otherwise, it'll just draw it like normal. So in the sprite class, I've added a boolean for remove. And so this is if the sprite needs to be removed, that can just get set to true. And we have an isRemove method, and we have setRemove method. In our sprite update, I added another method to the interface to setRemove, and so that can be done via the movement or wherever else sprite update is used. And then in our base movement class, I made some updates. So the calculate magnitudes takes this update speed, and that is now used to calculate the X and Y update. And this comes into play with the piece that I've just added for the movement. And then I created a new class called noMovement, which implements movement. And this is basically if there is essentially no movement for our sprite. Its speed would be 0, the X and update would be 0, and it does nothing. So that would cause the sprite to not move. Alright, here we are in the movement interface, and before it had the get X update and get Y update. And a previous framework that I worked on, I used those, and this framework I'm using a sprite update. So these two methods are not needed. So I went and I removed them. And so that's no longer part of the framework, because all of that X and Y update is handled through the sprite update. So in the actor class, if there's a collision, the collision is handled through the movement class. So the actor doesn't need to get those X and Y updates. The movement class will handle that itself. The next class I want to look at is a single movement class. And this is a pretty simple class where it is a single movement where you set the speed and the direction, and it doesn't change, and so it just keeps moving in that direction, and if it hits something, it just stops moving. Okay, now I'm going to cover the script movement. So this is the main purpose of this video, which is scripting the movement of an actor. And the script movement basically holds all of those movement actions that the actor will take. And so it contains a list of script actions, and the script actions are the specific movements that an actor can take. It has a current index, a current action for convenience, and a done flag. So if the script movement has gone through all of its actions, the done flag will be set to true. We have a default wait action of 0. I'll show you how that's used in a moment. So in our constructor, we're taking our script action. We add this wait action. This is so that the script action that's passed in can be set up correctly. And we can also verify that a script is done at the end of an update. And so we set our wait action as being the current action, and then we add in the passed in action to our list of actions. So the first action of the actor will be element 1. The add action method takes our action, adds it to our list. Now if our script movement is already done, the action passed in becomes the current action. The current index becomes that element in the index, and our done flag is set back to false, so that then the update will process and then it'll go into whatever the action is passed in. Getting the current speed, so if the script movement is done, it just returns 0. Otherwise it returns the actions speed, get direction, and also returns the actions direction. Now the script movement has a go to action, so you can specify a specific action to go to. So the index needs to be between that 1 and the size of your action list. And so it sets that to be the current index, takes the direction speed of what the current action is, the one that you're just leaving, sets the current action to be the new one that you've passed in, the new index, and then we call its setup method where we pass in our direction and speed. Handling the collision, the sprite movement basically just undoes the last action, so it stops the actor from moving. Simple Boolean check. This is a method that you can force it to go to the next action, so it just goes to next action. Here you can set the speed within a current action, and most of the time you probably won't do that, but that is there because it's part of the movement interface. The update method, taking our delta time and sprite update. So it checks to make sure that this movement isn't done. Checks the current action, see if he's done. And if the current action is done, it will go to the next action. So I'll hit that one in a moment. Then the current action, we do the update on it, passing in delta time and our sprite update. And after it does the update, we check to see if our current action is done. And then we check to see if our index is on the last element. If it is, then this script movement is done. Go to next action, and so what it does is it takes the current direction and speed of the current action, updates our current index, checks to make sure it's in bounds, and then it pulls that current action and then calls the setup, passing in the direction of speed of that action. Otherwise, what happens is it marks this script movement as done. The current action becomes our wait action, and we just call the update so that our direction is the same as when the previous action, so it doesn't change direction on us. Here is our script action, the meat of this process. It has a lot of variables in it. The X and Y update, the initial speed and direction, the speed, our change in direction, current time, duration, done flag, and change direction gradually flag. I'll go into each of these as I go through each of the action class. Simple getters for all of these, and check to see if it's done. So the setup method, what it does, it marks the done as false, and that's in case you reuse an action, it'll reset it. Current time is set to 0. I'll show you how that works in a moment. This is the initial direction and initial speed, so this is kind of the direction and speed of the previous action. So if you're moving at a speed of 1 and a direction of east, and that'll be your initial direction for the next action. And if you're set up to change direction gradually, so this does all the logic to figure out how to go from, say if you're going from 90 degrees to 180 degrees, it will split up the rotation from 90 to 180 gradually over your duration. So our update method in the script action, it has the current time plus equals the delta time, so that gives you how long this action has been going on, and then we call the update child. And the update child is implemented by our various action classes. Calculate magnitudes by direction. This is the same one from the base movement class. So the get updated direction allows for changing the direction gradually. If you're not changing the direction gradually, we just return the direction. Otherwise, it'll get the change in direction times your delta time and add that to your direction. And then we convert it to be between 0 and 360. The get percent complete, so this checks the current time divided by our duration, so that has our percentage that we're complete. So this is the setup changing direction gradually. And so what it does, so if your initial direction, that's 1, is in this quadrant between 0 and 90, and your other direction is between 270 and 360. Otherwise, if your initial direction is over here and your other direction is over here, so it adds 360 to your initial direction so that it can get the correct change in direction without having it go kind of the long way around. So otherwise it would have to go, to this quadrant, all the way around to here to get your change in direction. So it's making a long arc. And this is so it makes a short arc. Here it checks if your initial direction is either here or over here to over here. And so this does a calculation. It takes your direction, adds 360 to it, so that your direction is the shorter distance. So that's your change of direction. Otherwise, it just takes your direction minus your initial direction, divides it by your duration to get your change in direction, and then sets the direction to be what your initial direction was. So the first action I'm going to go over is the wait action. And so it is an action where the actor will wait at a given spot for a given duration. So you pass in your wait time for how long you want him to wait. And if your wait time is less than 0 or less, then the wait time is already marked as done by default. Also, you can set a wait time and a direction. So if he's waiting at a given spot, you can have him look a specific direction. So let's say your actor is moving south down the screen, and then he stops and he's going to wait and face to the right. So you can set that up. So the update child, so we do calculate the magnitudes, but it's no movement, so they end up being 0. So this is just to make sure that our sprite's location is unchanged. And if our current time is past our duration, then this wait action is done. All right, the next action I'm going to go over is the time movement action. And so what this action does is he'll move your actor over a distance at a speed for a certain time. So it has a direction, a speed, and for how long to move for. And so you pass in like 2 seconds. Move to the right for 2 seconds, for example. And you could also have him change direction gradually. So for example, if he was moving up the screen and you change direction, you're going to have him move now 2 seconds to the right. It can gradually go into the right direction over those 2 seconds. Otherwise, this one, he just makes a hard right turn and heads to the right. Update child's pretty straightforward. Calculate our magnitudes, add that to our sprite location, and we check to see if our duration has passed. Okay, the next action that we're going to look at is a change in speed action. And so this will have the actor go from, let's say, a speed of 1 second to a speed of 2. Right, so we have our final speed and our duration. So how long is he going to take to speed up or maybe even slow down? And you could also change your direction if you're changing your speed. And of course, like the others, you can do that gradually, so you can make essentially an arc as he either speeds up or he slows down. So here the setup, this one actually uses the setup as the others did not. So he takes the current direction and speed, calls the super setup method, and then so what it does is it takes the final speed that we want to reach, subtract what the current speed is, and divide that by the duration. And so that's our change in speed over time. And so then we set the current speed to be the initial speed. And so in the update child, the change in speed is multiplied by delta time, and we add that to speed. And so after it goes over that time span, that speed will be what we had originally passed in. Update our magnitudes and check to see if we're done. I'm going to go over those actions that I just covered. So we're going to start by making a new screen. So we'll just create a new class here, call it our script screen. And we'll extend our simple, not simple test, but simple screen. And then we just need to implement our show method, which is basically our setup method, right? We'll start by setting the background color. We'll just make it white. And we need to set our game tutorial to use our script screen. All right, and then we're going to add a texture, and we have a demo character we're going to use, character 2A, PNG. And of course that is a 4-way motion. Take our texture, 64 by 64, and 0.2, and that's going to be 3, 2, 0, and 1. And then we need to get our texture region, right, and that's going to be splitting. Take that same texture, 64 by 64. This is for our still image, our 4-way motion. That's our still, a new 4-way motion. And we need to do a new static region animation. I'll take our texture region. I'll start with 3, 1, and I'm just going to copy this. And this one's going to be 2 and 1, and this one's going to be 0 and 1, and this one's going to be 1, 1. So that'll be the character standing still. And so we're going to create a script movement. It's going to be our movement, new script movement, and we're going to start by changing our speeds. We're going to change speed action, and our final speed is going to be 0.08, and this will set them into a direction of north, and a duration of 3 seconds. So he'll go from 0 to 0.8 pixels per second in 3 seconds. And then after that movement, we're going to add another action, and this time we'll do the time move action. Show you how that one works. Set our direction, we'll go east. And a speed of 0.8. I'll go for 4 seconds. Then we're going to add another action where we'll do a wait. Wait for 1 second, and we'll have him face south. And then to finish it off, we'll add another action, another time move action, and this one will go back west. Speed 0.8, and we'll only go for 2 seconds. And we'll create our actor, a new actor. We'll add our movement, the motion, and the still. And we'll set the location. We'll start him out at just 50-50, so he's not in the quarter. And then we'll add our actor, and then we'll run that. There you go. So he's speeding up. So you see he's getting faster. And you go over to the east, and he's waiting facing south, and then he goes back to the west. And it completes the entire script. And so that's how that works. So if I take out this movement and take out the wait and just have him move north. And then we'll set this one to change direction gradually. We'll go east and then gradually turn to the north, and you'll see how I'll make kind of an arc. So he's speeding up, going to the east, and then he'll gradually go up to north. So he kind of makes a circle. And that's how that gradual change in direction works. The next action I'm going to go over is our destination action. And so here we have an initial location, X and Y, and our goal location, X and Y. And this is a Boolean flag. I'll show you how that's used in a moment. So our constructor set our destination. We have our goal, X and Y, and how fast we want to go to get there. And our other constructor will take a change direction gradually with that goal and the speed. And our update child, so what happens here is we get this current sprite's X and Y location, and then we check to see if our direction speed was set. So it starts out not being set, and we set it to true once we get through this method. And so this is the initial setup. So we set our initial X and Y, and then we take the initial, subtract our goal to get this X1 value, and what we do, and we do the same thing for the Y. And what we do is use Pythagorean's theorem to get F, and F is essentially the distance between the 2 points squared, and so we get the square root of that, and that is our distance. So we take our distance, divide that by our speed, and then we have how long it's going to take to get there. And then we set the change in direction to equal basically what that direction is minus our initial direction divided by our duration. So every other iteration of this update child, we get the direction based off of our X and Y location to the goal, and we calculate our magnitudes, and we call the get update direction. And so if we're changing it gradually, it'll use this change in direction. Otherwise, it will just be the direction that was originally passed in. Now, the next thing that we do is we check to see if our goal is moving in a positive X or a positive Y. And so this is, we can calculate if we reached our goal and not gone past it. So we check to see if X doesn't equal our goal and Y does not equal our goal. Then what we do is we get the current X, add our X update to it, and if we're moving in a positive direction, we check to see if our new location of X is greater than our goal. Because if we're moving in a negative direction, we're checking to see if it's less than our goal. And if it is greater than our goal, then we set it to our goal. And in the negative direction, we set it, if it's less than our goal, then we set it to our goal. So this keeps the actor from moving beyond where we want it to go. So once we get past that logic, we set our X location to that new X location. And then we do the same thing for the Y. So if our X and Y location meets our goal, then we just calculate magnitudes for moving no speed and our updated direction. And then we do a check to say, hey, if we reached our goal, then mark this action as done. And so that's how the destination action works. This is the easing action, and so what it does is it changes the velocity, but it'll ease in or ease out. So if it's easing out, it's decelerating. And so as it gets closer to where it's going to stop at, so it'll slowly decrease the speed until it reaches 0. And I'll show you how that works in a moment. So here we set our duration, our easing power. So easing power is an enum. We have either bi times 2, a tri, which is times 4, quad times 4, and a quint is times 5. So our easing action constructors, for doing an ease out, we have 3 of them. Each of them take a duration and an easing power. This one takes a direction, and this one takes a direction and changes gradually. And so we set our duration, direction, easing out to true, And the easing function to get the new velocity is here. It's the same for each one. So this one that doesn't take a direction, we'll set the direction to -1, and so it'll use the direction from the previous action. And I'll show that in detail in a moment. Now we have these two easing action constructors that will ease in when they're accelerating. So these are actually going from 0 or from some low speed to a high speed. And so what we do is these take a speed, a direction, a duration, and an easing power, and this one will change direction gradually. We set our duration, our direction, the initial speed based on what's passed in. I'll show how that works in a moment. And our easing supplier, this is the function for getting our change in velocity. And we have a set speed method, so if you're easing out, you can set your initial speed. And so in the setup method, we set our done to false, current time 0. If it's ease out and our direction is -1, we take the direction that a previous action had. So if you're speeding up, it's assumed that you don't have a previous direction. And then we set the initial speed equal to the speed. So on our update child, so the initial speed is times the easing power, and that's these powers here, and it checks based off the % complete. And so then we get the updated direction based off of the delta and their speed. We calculate the magnitudes, set our location, and then this is our easing power enum. Okay, and our last action is the go-to action. This has a reference to the script movement. It has an action index and a repeat number. And so our first constructor takes that parent script movement plus the action index that you want it to go to. And so the action index just needs to be greater than 1. So if it's less than 1, it will throw an illegal argument exception, and then it will set the action index. This constructor also has a repeat, so you can have a set of actions repeat a set number of times. And so it then sets all those. So in the setup method, it'll call the super direction and speed. So then it checks to see if the repeat is not equal to 0. And it will call the parent's go-to action, passing in that action index. And if our repeat is greater than or equal to 0, then we will do repeat minus minus, so it'll decrement that. Otherwise, if the repeat equals 0, this will be marked as done. So the update child does nothing, and the reason for that is because this is in the setup method where it's changing to the next action, and we call the go-to action, and what it does is it changes the current action to be whatever that index is and calls it setup. So the go-to actions update method actually never gets called. Okay, now I'm going to go and demo those actions that I just went over. So we'll go back to our script screen in our tutorial, and we're going to start out by doing an easing action. And so what we'll do is we'll start with one float, set a direction equal to east. So we're going the east direction. We're going to go for 10 seconds so that you can actually see it in action, and then we'll set the easing power to the 3 times the power. All right, and then we're going to set the next action to be a destination action, and we're going to go to 250, and we'll do a speed of 1, and I'm going to copy that for our other directions. So now we're up in kind of the upper right corner, and we're going to go back to the west to 5250, and we're going to go south down to 5050, and then we're going to go east to 25050, and that'll make a square. And then to finish that off, we're going to use our go-to action, pass in our parent, and we're going to start with that second action. So this is easing action is 1, and this action is the 2. And we'll run that. And right, here you go. He's easing in, so he's starting out slow, and he's picking up speed. And then you see he gets faster until he gets that full speed. Now he's going to the first destination, going to the next destination, then down, and this is the last destination. And at this point it does the go to action. Now he's going back into the first action in there, our square. So he just keeps making a square, and he'll repeat that action. So that's going to do it for this video. It covers all the script actions, and that'll help us make a video game a lot easier for our NPC type of characters. And the next video I will move into actually making a video game, a rather simple one, and show you how to use the framework to do that. So if you like this video, give it a thumbs up, feel free to subscribe, and I'll see you in the next video.